I've got a lot of questions asking how, if you just look at the reactants, can you determine what type of reaction it's going to be? So apparently there's some confusion around this, so I hope we can clear it up. If the reactants are just two elements, there's really not much that they can do other than combine into something. So if you look at it and it's two elements, then it's definitely going to be a synthesis reaction. And more times than not, and almost always, let's go always in the class that I teach, that combination, that synthesis, is going to be the production of an ionic compound. So you're going to take these elements and you're going to make them into an ionic compound according to their charges. So you don't just get to glob the two elements together and then say, oh, there you go, they joined together in a compound. No, they're going to form an ionic compound, and the formula for ionic compounds is based on the charge of the ions when they gain and lose electrons. The next one, and it's pretty easy to spot, if you only have one reactant, there's nothing that can replace something, there's nothing that can join together. That one reactant is going to decompose. It's going to break down into simpler things. So, one reactant, it's going to be a decomposition reaction, and then if it's a decomposition reaction, it can either break into its constituent elements, and that's pretty common in terms of the types of questions a chemistry teacher might ask. And then there are some special cases of decomposition. For instance, there are chlorates, which break down into metallic chlorides and oxygen gas. And then there are also carbonates. Those break down into metallic oxides and carbon dioxide gas. And so, if you're interested in that, there's another video on decomposition reactions. Check that out. But you can recognize that it's got to be a decomposition reaction because it starts with only one reactant. And then there are three more. If you have the reactants are one element plus one ionic compound, then what's going to happen, that one element is going to try and replace its analog in the ionic compound, and that's going to be a single replacement. And lastly, if you're given two ionic compounds, all right, so in those two ionic compounds, we're going to see, are these the most stable configurations? Or if the cations switch places, so cation A goes with anion B, and they switch dance partners, they do a do-si-do, then that's going to be a double replacement reaction. And then lastly, we have hydrocarbon combustion reactions. And how do you recognize a hydrocombustion reaction? Well, you're going to have something that is made out of just hydrogens and carbons. All right, so something like C3H8 or CH4 or C8H18. All right, something that's made out of just carbons and hydrogens. It could even have an oxygen thrown in there, but for right now in my class, just something made out of carbons and hydrogens. And then combustion, it's going to be that thing plus O2. And on that one, we've talked about it since I think the third day of class, the products are going to be of a complete hydrocarbon combustion are going to be carbon dioxide and water. So that has not changed. That's going to be the same as it has been for a long time now. So that's how you can tell the 5 different types of reactions and hopefully classify them. And then by classifying them, you can decide how to rearrange the different elements in the different compounds to figure out the potential products. So hopefully that helps. Hopefully that clears something up for you.